My name is Trevor Dyke. I'm a Senior Manager of Product Management in AWS. My focus is on messaging services. So I work on services like Amazon MQ, SQS, and SNS. And we're going to talk a little bit about messaging today as it applies to application migration. If you're not here to hear about messaging, we're going to talk a bit at the beginning about kind of general migration strategies, but the core of the presentation is going to focus on messaging in case you weren't aware. It was in the abstract, it's not really clear on the title, so I just wanted to mention that. So we're going to kind of start at a higher level, and we'll talk about things you need to consider when you're migrating to the cloud, and specifically from on-prem to the cloud, but even from other data centers, other cloud providers. Then we'll talk a bit about message-oriented middleware, message brokers, and how that applies to your migration. And as I said, the core of the presentation, we're going to focus on messaging and strategies for migrating your message brokers. And then I'm going to jump into kind of a three-step process for how you would migrate your applications and your messaging infrastructure. So step one, evaluating if you can migrate. Step two, doing a proof of concept. And then step three, some strategies for non-disruptive migration. And I'm going to do a very short demo as well. I wanted to mention some related breakout sessions as well. So we've got 3 sessions that are related. Specifically, the first 2 are the most related. So there's API313, which is it's actually a builder session. So in that session, you actually get in and do some tasks. You actually build a bridge solution from IBM MQ to Amazon MQ. So I encourage you to check out that one. That's with my colleague Mithun Malik. And then there's API307, which is about building efficient and scalable distributed applications using Amazon MQ. And that's a chalk talk, I believe. And then the third one, API312, is about how to select the right application integration service. So that covers things like when to use streaming versus messaging, when to use different types of messaging services. We'll talk a bit about that today as well, but that's another session if you're interested in this area. Okay, so let's get started, and let's talk about first of all, at a high level, what are the things you need to consider when you're migrating? What are the challenges and things you need to think about? So when you're migrating applications to the cloud, there's several important things to consider and guide your approach. Obviously, business goals is really the most important one, and it may be several of these, it may be all of these, but think about really which ones are the most important, and what's driving your migration to the cloud. Is it reducing cost? Is it increasing productivity and agility, scale, reducing operational overhead? Think about the priorities, because that will actually guide your strategy, and we'll talk a bit about how that maps to strategies in a moment. Also, application capacity. So think about both the capacity you need now in your on-prem or your existing environment, as well as down the road. Is it going to need to scale up? Do you need to think about short-term peaks? And then last but not least, the cost of migration. So are you optimizing for a low-cost migration, or do you have more budget for your migration? So some of you may have seen this before. We have a white paper actually available that talks about this. So there's 3 key strategies we see customers using and that we kind of recommend customers look at for migration. The 3 R's: rehost, replatform, and refactor. And depending on your business goals, each one may make sense, and sometimes they can be used in combination. Another thing that can make sense, and we see customers doing, is kind of progressing through these 3 strategies almost as stages. So starting with a rehost, then maybe a replatform, then a refactor. And as you can see from the axes, each one is progressively increasing in cost, effort, and skills on the left side on the vertical axis, and then also time to migrate. So this is where your kind of goals, your business goals, and your budget come into play when you're thinking about your migration. So let's talk about each one. So first of all, the rehost strategy, and this is sometimes called lift and shift. It entails lifting part of the application or a complete application from on-prem to a new cloud environment. In a large legacy migration scenario where your company is looking to migrate quickly to meet a business case, we often find a majority of applications are rehosted in that scenario. For example, one of our customers, GE Oil and Gas, they found that even without implementing any kind of cloud optimizations, they saved about 30% of their costs just by doing a rehost. And in this situation, you're really shifting with very little or almost no modification to your applications. Once customers migrate their applications using this rehost approach, it's easier for them to re-architect and optimize. So then you can actually progress through other stages after you've done this initial stage of just migrating or lift and shifting to the cloud. So when should you choose this option? Key things are when your largest concern is the cost and the time to migrate, if you're trying to minimize that. If you want to reduce your on-prem costs immediately, if you need to get out of a data center facility, for example. If you really need minimal disruption, and if you're using commercial and off-the-shelf apps, so if you have something you've purchased from another vendor and you obviously have no opportunity to refactor or recode that, then this is obviously a key approach for that. Okay, so that's rehost. Replatform, that's the next one. And unlike the lift and shift approach, sometimes we call this lift, tinker, and shift. This is where a portion of the app or maybe the entire app is optimized a little bit before moving it to the cloud. Sometimes we can see small optimizations that can bring significant benefits without changing the core application. For example, suppose an organization is managing their databases on-prem, which requires a significant amount of time. They've got database analysts and database resources managing that. The time required for managing that database can be significant, and it can be reduced by moving that over to Amazon Relational Database Service or Amazon RDS. So that's a very typical example of a replatform approach. And allows customers to use the resources they're accustomed to working with, so maybe the databases or as we'll talk about in a moment, the message broker they're familiar with, but take advantage of kind of the lower costs and the operational overhead of moving to the cloud. So when would you use replatform? Really when you want to get additional benefits from the cloud, like offloading that operational overhead, which can be, as I mentioned, a significant concern. If you want to increase automation, you want to improve availability or performance, all those things can be achieved with a replatform approach. And if the on-prem infrastructure is complex and it hinders scalability and performance, replatform can also be effective. An example here is a large media company we were working with, migrated hundreds of their web servers that they were running on-prem into AWS. And in the process, they moved from WebLogic, which is a Java-based Java application container that requires some expensive licensing. And they moved that all to Apache Tomcat, which is like an open source equivalent to WebLogic. And this media company saved millions in licensing costs on top of the savings it gained by migrating. The third approach is a more radical approach, and it's refactoring. So refactoring is making major changes in the application configuration and the code as you're migrating. So this is typically driven by a strong business need to add features, to scale, to add performance that would otherwise be very difficult to achieve in the application's existing environment. It's a more complex approach than the other two approaches, because you have to ensure the changes don't negatively impact your existing application features and functionality and performance. So refactor, depending on your needs, you can do a partial refactor where a small part of the application is modified, and that results in a faster migration compared to a full refactor. An example here is taking a monolithic application. So maybe you've something you've designed as a monolith and it's running maybe on a single server, single cluster, and modifying it to use microservices, typically using either AWS Lambda or containers, maybe ECS. So this is really making maximum use of the latest cloud native technologies in AWS, and you're going to yield a lot of benefits from that. And obviously it does include more time to do your migration and more cost. So when should you use refactor? The key things are when there's a strong business need for adding features and performance to the application, and that's not possible with your existing architecture. When an organization is looking to scale their app dramatically, particularly if you have high variability in your performance and scale, Serverless technologies work very well in that kind of environment. And really just to take full advantage of everything AWS and cloud capabilities have to offer. So maximum availability, performance, scaling, and actually the lowest costs, pay-as-you-go, and things like that. So it's generally the best long-term approach, but it's the largest change and the largest upfront investment. So that's kind of a general discussion of migration of any application. What I want to talk about today is your application integration layer. And application integration, it's a broad topic. Typically, enterprise apps we see using various technologies or methods to integrate. We see APIs, we see orchestration or workflow. And most commonly, I would say, or very commonly, we see messaging being used or message brokers. And that's what we're going to talk more about today and dive into a little bit more. So as a refresher, I'm sure everyone is quite familiar with this. Let's begin with a quick reminder of enterprise messaging. So generally speaking, messaging is used when you have a loosely coupled system. You want to build a loosely coupled system that needs to scale to be large, highly reliable, fault tolerant. And you have applications or application components that need to communicate via messaging, and that's typically message queues. It's also used in applications where you have any multi-step transactions or workflows that must be completed in a very reliable manner. And it's very common in many industries, many verticals, in the enterprise and in the startup space as well. For example, in financial services, messaging is commonly used for financial transactions, for stock trades, for anything that has to be completed and completed without error. And in most enterprises today, messaging is implemented in what's known as message-oriented middleware, or a message broker, sometimes called. And that allows information to be passed between software components or in applications to communicate between the components, minimizing the need for the components to know about each other. So it adds that decoupling versus API to API integration where both sides need to be aware of each other. So let's talk a bit about migrating existing message-oriented middleware. Let's say you're using message-oriented middleware in your on-prem or your existing environment and you're moving to AWS and you're wondering, how am I going to deal with my message-oriented middleware? So traditional message-oriented middleware or message brokers that we see customers using today, there's a broad variety of them. There's dozens actually. And some of these you may be using yourself or you may have used in the past. So probably most people are familiar with IBM MQ or WebSphere MQ and Tibco. These are probably the most common we see in a kind of more traditional enterprise environment. We also see customers using open source software like JBoss AMQ, which is based on the ActiveMQ open source from Apache. Also RabbitMQ is very popular. Less so on-prem, we see that more actually used in AWS. And there's many others, as I mentioned, there's dozens. There's Oracle has as a queuing service, that's part of their WebLogic suite. There's Microsoft message queuing, there's SonicMQ, and many, many others. And many of them, they have a lot in common. They're using similar APIs, similar protocols. They have slight differences. But what do we want to do, or what can we consider if we want to rehost or migrate one of these applications, or one of these message brokers, sorry. Let's get a quick drink. So just like we talked about for applications, for your message broker, you can apply the same 3 strategies: rehost, replatform, refactor. So we'll talk a bit about what does that mean actually in the messaging context. Hello, audio? Can you hear me now? Hello? Now? Technology, huh? Well, I'll keep talking because nobody else is here. You can hear me, right? until he turns the audio back on. So can you hear me okay? My voice is carrying all right? Okay, so migration for message brokers. The same three strategies can apply. There's a rehost, replatform, or refactor. Now, can you hear me? Okay. I don't know when other people are coming, so we probably should use the headphones. So firstly, you can run your existing message broker in AWS. So maybe you're running IBM MQ already, you're happy with it, it works well. You can move that directly to AWS. We typically see people doing this running in Amazon EC2 or Amazon ECS or the Kubernetes version of ECS, which is EKS. And we actually have some quick starts, AWS quick starts available. We have one for IBM MQ and one for TIBCO EMS that will help you actually get that migration done. And there's also AWS Marketplace offerings for RabbitMQ, for some of the other open source ones that will help you actually migrate or build an instance of your existing message broker on AWS. And that can be a good approach, and particularly where you're using very specific capabilities of that platform. The downside is, you still have to manage your own message broker. The infrastructure is managed, so EC2 or the container service is taking care of the infrastructure for you. But you still need to manage your message broker. You need to worry about things like patching and any other kind of operational issues. The second approach is replatform. And replatform is where we would recommend using Amazon MQ, and really why we developed Amazon MQ and launched it 2 years ago here, actually at reInvent. And Amazon MQ provides an API-compatible managed message broker service. So it's compatible with the common APIs you see in the message brokers we were talking about, and allows you to offload your broker management to Amazon. So we're getting paged at 3 a.m. instead of your DevOps folks. And it reduces your operational overhead and cost. And it's less disruptive than a refactor. So we'll talk in a minute about refactoring, but it's less disruptive than a refactor. It yields more benefits than a lift and shift. Now, you can also do a full refactor, which will yield even further benefits, but takes more time. So in this approach, though, you can often, we see customers doing this with very little code change, sometimes even no code change and just some configuration change. The third approach is the refactor, and this entails writing or rewriting parts of your apps to use our serverless AWS native cloud messaging services. So that's Amazon SQS or Simple Queue Service and Amazon SNS or Simple Notification Service. SQS is a managed message queue. SNS is a managed topic service for pub/sub patterns. And you should consider this if you're refactoring your applications, especially if you're moving to a full serverless kind of architecture. So if you're refactoring to use Lambda, or even if you're refactoring to build on microservices using containers, this can be a really, really good approach. SQS and SNS add some additional benefits beyond what you get with Amazon MQ. In fact, they scale nearly infinitely. I was just told that on SQS, we've reached 25 billion requests per hour in terms of the volume of traffic we're handling from all of our customers recently. So it's a nearly infinite scale. Hopefully you're not doing 25 billion messages per hour yet. But there's some upfront investment to refactor your code. So it's definitely something you should consider, and we encourage customers to look at these two or these three really approaches. So another way to kind of think about this is a comparison of operational responsibility. And some of you may have seen a slide like this for some of our other services. But at the top end, really you only worry about managing your code, and AWS manages everything else. In the midpoint there, AWS is managing your infrastructure and your broker, but there's still some things you need to think about, like scaling, provisioning brokers, and your own security configuration. And then at the lower end is kind of the least managed, the rehost approach. And AWS manages your infrastructure, but there are many things you need to manage yourself, including software updates, patching, provisioning, all those kinds of things. So just another kind of perspective on this. So when you start migrating to the cloud, you have to consider your options for migrating your messaging-based applications. And in some cases, you're migrating an application that's mission critical. So something that's really critical to your business. It maybe has kind of a big risk to your business to move it. It's really a critical part of your operations or your business overall. And failures could be a big risk. So that's something where you really need to think about a non-disruptive approach, which is what we're going to talk about today. So much like your enterprise databases, this is probably an application where you've invested significantly over the years, both in the people to manage the system and in the licenses and the knowledge and the technology that you've built up over time. You've probably been paying high license fees, and the commercial support you have gives you a sense of comfort. If you're managing your own, you still have to worry about availability. You're probably worried about losing messages. That always comes up as a concern, and you might be worried about scaling to meet your business needs. So, and in most enterprises, we see customers using a combination actually of commercial and open source for these mission critical applications. So what I'm going to talk in more depth about today is one non-disruptive strategy. So we talked about various strategies. I'm going to dive into the Replatform approach a little bit more and how you can replatform with Amazon MQ. It's not to say that the other approaches can't be effective as well, but this is the one we're going to talk about because I think there's some interesting approaches here. And we've seen customers effectively move mission critical apps using this approach. So let's talk a bit more about how you can do that. So as a reminder or something new for maybe those of you who aren't familiar with Amazon MQ, we launched it 2 years ago, as I mentioned, here at reInvent. It's become extremely popular, in particular with customers doing migration. And it allows you to migrate without rewriting your messaging code because it's compatible with these industry standard APIs and protocols. The key ones being JMS and AMQP, I would say, are the two we see most commonly used. There's Stomp and MQTT and WebSockets are also supported. There's NMS, which is a .NET variant of the JMS specification. So because of that compatibility, it makes that migration really much easier. And because it's open source, it's based on Apache ActiveMQ, that adds a lot of benefits as well. Many of our customers really appreciate the open source aspect. So some of the nice things about Amazon MQ, because it's using this open source product that's compatible with standards, it supports the majority of the key messaging features that you'll see in your existing message brokers that we discussed before. And many of those are going to be used or might be used in your current applications, so you really need to think about and evaluate which features are going to be important for you. So some of those features include the protocol support I mentioned before, so very broad API compatibility. It provides queues and topics in a single service, so you can easily build pub/sub or fan-out patterns and build durable queues. It has the concept of both transient and persistent messaging. So transient messaging where messages are only persisted in memory, and then persistent messaging where they're stored on persistent storage. One can be used to achieve higher performance, and the other one can be used to achieve more reliability. Messages can also be ordered, so it supports FIFO ordering. Messages can be ordered by message group. It's part of the JMS specification, so it supports that. You can use things like message filtering to use selectors for content-based routing. Large message sizes are supported, so we find a lot of customers, or some customers, let's say, are in some of their older applications have used messaging for some patterns where they maybe have large messages that are several megabytes. SQS and SNS, we support a 256 kilobyte message size. So sometimes if you have apps using large messages, this can be an effective way to deal with that. So there's no soft or hard message size limit. When you're looking at performance, the performance is impacted if you have really large messages, but we don't impose any limit there. It supports features like message delay and scheduling. And it supports things like distributed transactions to manage complex multi-stage transactions, such as database access. Again, something we see often in some enterprise applications that are coming from an on-prem environment. Other features, virtual and composite destinations. So those are patterns that allow you to build more complex kind of messaging patterns, and complex redelivery policies. So much has quite a few different configurations in terms of how you're going to handle redelivery. So I thought I'd talk about a little bit of a case study, and I'm only allowed to use certain names that are allowed, so we're going to call them Example Corp. And this is a typical enterprise, so I kind of picked this because this is a very typical customer we see. And they're migrating to AWS. They have several legacy applications, for example, billing and inventory, and they have an objective to build their newer apps in the cloud. So they want to move to the cloud. They want to just lift and shift really those existing apps, but they want to take advantage of things like machine learning and analytics and some of the newer capabilities in AWS. And their company or their IT team's given them a mandate to migrate to managed services wherever possible, just to offload that operational overhead from their IT teams and let them focus on more core problems. So for this company, a replatform approach really makes a lot of sense. They can move their unmodified applications to the cloud, and while just replacing their message broker to get advantage of that managed service. And since their apps are using standard APIs like JMS, they can use Amazon MQ in this case. And then Amazon MQ or Amazon AWS manages the broker. They don't have to worry about managing availability. They don't have to worry about losing messages. And they overall get better application reliability. And they no longer have to pay for those expensive licenses. They just pay on an hourly basis for their message broker. So for this Example Corp, how would they actually go about doing this? What are the steps they would take and go through? And some of this may be obvious, but I think it's worth covering. First of all, the first step is really evaluating, can you migrate your application? And this is a fairly obvious step. It's an important one. You need to assess the messaging needs of your application. So your broker might support all kinds of features, but what is your application actually, or your applications? What are they using today? So consider the use cases. Are they using just queuing? Are they using pub sub? Are they using transactions that we talked about? Are they using request reply patterns? Do they require message ordering, or is message ordering not an important factor? How tolerant are they to availability and durability? Are they applications that are okay if occasionally messages are lost, or do they have to preserve all messages? And that really depends on your use case. And performance. We'll talk a bit more about performance in a few minutes, but performance is an important consideration. What needs do you have for performance today? Try to get a benchmark or an idea of what performance you see in your existing on-prem broker. Security and compliance, of course, is an important factor. You need to think about what security do you have on-prem today, but also what new requirements do you have in a cloud environment? We often see customers that have fairly loose, let's say, requirements on-prem or haven't implemented a lot of security, and they're moving to the cloud and they're really thinking about, hey, I need encryption at rest, I need encryption in transit, I need to think about all those things. And of course, monitoring and logging. You may have some of that already in your on-prem environment, and you need to think about that in the cloud. Now, if you get to this step, and what if all your requirements aren't met? That can happen. So there are corner cases or features that are supported that might not be available in any of the Amazon messaging services. So first thing is double check, because concepts in existing systems have different names. So for example, one I like to bring up, and we brought up here, is in RabbitMQ, there's a concept of exchanges, and the similar concept in Amazon MQ and ActiveMQ is called virtual topics. So someone might say, hey, you don't support exchanges in Amazon MQ, I can't move, but it's actually just a different name, and there's actually very minimal changes you can make to repeat that pattern. So make sure the current concepts map to your terminology. We're actually going to be publishing a white paper in the next month or so that maps some of the concepts from some of the popular message brokers to Amazon MQ. So that will, I think, help. Secondly, just make sure, are those features still needed? Sometimes we see customers saying, hey, I'm using this feature, like transactions would be a very common example here. And when they look at the architecture, they decide, actually, there's different approaches we could take instead of using transactions or distributed transactions. They may not want to use or need that feature anymore. But if you do find there's capabilities that aren't available in the existing or in the Amazon messaging services, then you may need to consider a rehost or a lift and shift approach and take an approach of moving your broker directly to AWS. But let's go back to this case study of Example Corp. And so this is their current on-prem situation. So some of the things I talked about previously. So they have 4 applications that are using their message broker. They're using JMS 1.1 APIs to send and receive messages. They have about 20 queues. Only 2 of them require ordering. The others, ordering is not critical. But messages can't be lost in these applications. These are all business critical apps, and we can't lose messages. They can't have any downtime during migration. They don't give their customers or their internal customers an SLA, but they can't have downtime. It's an important part of their business, and migration or downtime during migration is just kind of a showstopper. Their total throughput requirement is 1,200 messages per second, fairly moderate. They don't have any encryption today on-prem, but they have a new mandate in the cloud that everything they do needs to be encrypted. They're a healthcare company, so HIPAA compliance is also important. And for monitoring, they're using some JMX-based tools for monitoring. In this case, it's a third-party product called Nagios. So let's map those requirements to Amazon MQ. So Amazon MQ is JMS 1.1 compatible, so we tick off that. It supports FIFO queues, we tick that off. Amazon MQ has persistent storage across multiple AZs. And I'll talk a bit about this in a moment because there's some things you need to think about regarding performance. But it's designed for 11.9's durability. So the same durability it's designed for the same durability you'd see in S3, which is also 11.9's. In case you can't count that there, that's 11.9's. So with applications where it's really critical you don't use messages, this is a really key advantage. So every message is replicated across multiple availability zones. AZs, as I'm sure you know, are separate physical facilities, separated by distance. So the durability is really good and really helps for this migration. Amazon MQ, for the availability side, it provides active standby message brokers with 99.9% uptime SLA. We have a service level agreement there for that. Performance, I'm putting a question mark there because we're going to talk about that in a moment. And Amazon MQ enforces mandatory TLS on all connections, so there's some added security there. So one step we often see in the migration is that customers are using OpenHTTP, so they do need to move to TLS, and most customers are happy to make that change because they get that added security. Provides encrypted storage with customer-managed CMKs or customer master keys, so you can manage your own encryption keys in our AWS key management service. It is HIPAA compliant, and for the monitoring piece, we're recommending this company use CloudWatch. So we've integrated with Amazon CloudWatch, so they're going to move from what they were doing with Nagios to CloudWatch, and that gives them an integrated monitoring view across their AWS services. So the next step is we're going to do a proof of concept. Once we've evaluated that we can move and we are comfortable that all those features are supported, we're going to do a proof of concept. And here what we'll do is we'll lift and shift an instance of each of their applications, so not the live production versions, but an instance of them into AWS. And typically this would be EC2, but it could be ECS or EKS as well. And what we're going to do here is the goal is to ensure everything's going to work with this new environment, with this new message broker. So first we install those on-prem applications, as I mentioned. Then we create the Amazon MQ broker, and I'll talk a bit about performance, but here Amazon MQ brokers come in different instance sizes, much like EC2 and RDS. So we would recommend a 2x large instance size for the throughput requirement they have. And because of their availability requirements, we're going to recommend an active standby broker, which is a pair of brokers across 2 availability zones that will fail over in the case of any issue with the active broker. And we're going to modify the app configurations to use the JMS endpoint in Amazon MQ instead of IBM MQ. So we'll do that one at a time. And in a moment, I'm going to demonstrate actually how we would do that with a sort of simple demo. And then we're going to run these applications. We're going to ensure the messages are flowing. We'll do that using CloudWatch to monitor the message flow through our queues and topics. And then we're going to test the performance and make sure that we can achieve performance. So let's talk a bit about performance, because this is often a topic that's misunderstood or needs some explanation when we're doing migration. So when we're thinking about performance in messaging, we need to think about both throughput, which is your number of messages per second, your latency, typically in milliseconds, and the number of connections your applications have, your producers and consumers, to the broker. So a common issue we see is, hey, I got some number of megabits per, messages per second on-prem, and I'm only getting Y with Amazon MQ, and often Y is less than X. So why is that? Well, often in an on-prem environment, we see a fairly simple storage mechanism, so maybe a RAID array that's in a single rack. And if customers are already on EC2 and they're moving to Amazon MQ, they might be using a single AZ available storage, like EBS. So their storage is in AWS, but it's only in a single AZ availability zone. So it's important to understand that, and we haven't talked about this much before in previous sessions, but we're actually, under the hood, we're using Amazon Elastic File System, which is an NFS-based multi-AZ storage. And as I mentioned, that replicates across multiple AZs and gives you that super high durability, that 11 nines, which it's designed for. But that comes up some performance trade-off. So there is a performance difference you're going to see by getting that advantage of the additional durability. So everyone will ask, well, how fast is Amazon MQ? You don't really publish any metrics on your site. So the answer is really, it depends, unfortunately. I can't give you like a very simple answer. It really depends on your use case. But I'm going to give you here some guidelines. Customers ask for guidelines, and I think this really can help at least give you a rough idea, but we really recommend you test with your use case. So some of the things that impact performance are things like the number of producers and consumers you have. So within each application, you can have multiple producers and consumers. JMS and these other protocols support that. So that has a big impact, as you can see in the left column there. As you increase the number of producers and consumers, even with the same size broker, you get much higher throughput. The message size is super important. This test was done with 1 kilobyte messages, which is actually a fairly common message size. But as I mentioned, we support big messages too. So if you're using 10 megabyte messages, you're going to see much lower performance than this. There's some broker settings, which I'm going to talk in more depth about in a moment. But there's a concurrent store and dispatch setting. That's a very important setting. And we have recommendations for you on how you should set that to achieve the best performance. And there's a link here. You'll get these slides after. You can access them. But this link will show you how to benchmark your performance using a JMS benchmark tool. So let's talk a bit about tuning performance. And I wanted to talk about this again because this is a topic that comes up a lot. So first of all, you can use if you can use non-persistent mode, which is memory only, you're going to get much higher performance. But you'll have to be able to tolerate message loss. So if your application is something like stock ticker quotes or sports scores, which one of our customers we talked with last year, Turner Broadcasting, is using, those kind of things are data that if you lose it, you're going to get a refreshed version of that score in a few minutes or a few seconds. So losing a message is not critical. So if your application is something like that, think about using the transient or non-persistent mode. In terms of protocols, we find the binary protocols are faster than the text-based protocols. The concurrent store and dispatch flag, which I'll talk about in the next slide. The number of connections, that's another thing that impacts performance, or you may require a given number of connections. And we've limited, the default limit is 1,000 per broker, independent of size. But you can send us through support portal, you can send us a service limit increase, and we'll raise that up for you. The larger the broker size, the more memory, the higher we can raise that. I know we've done up to, I think, 10,000 connections we've raised for some customers. So if you have a need for more connections, don't assume that 1,000 is like a fixed limit. And there's a feature called Network of Brokers, which can be used to horizontally scale and distribute the load across more nodes. One of the sessions I mentioned earlier dives a bit deeper into that. If message ordering is not required, because the queues are actually distributed across multiple nodes, and so you can't necessarily preserve message ordering, but that can be an approach as well to get higher performance. Another important tip, and I'm bringing it up here because we frequently see customers just with non-optimal settings. So ActiveMQ, the nature of ActiveMQ is it performs best when you have fast consumers. So what do we mean by fast consumers? That's when they're keeping up with the messages produced. So if the nature of your application is that you have kind of fast producers and slower consumers processing those messages, then we recommend you set this particular flag, this concurrent store and dispatch flag, to false. And that will actually ensure the best performance for your use case. And it's often a quick fix we see customers using when we see issues with performance. So I wanted to give you that tip. It's also in our documentation, but people often don't notice it. So, okay, so those are some tips. That's how you would think about migrating, the POC you would do, and how you think about performance. The third step is how are we going to do this non-disruptive migration? So there's a couple of different options here. So the first one I'm going to talk about is just migrating, taking your existing broker and moving to an on-prem broker. Or sorry, moving from an on-prem broker, migrating that into an AWS, a managed broker with Amazon MQ. So I'm going to go through some fairly prescriptive steps here, and this is a fairly simple example, but I think will help demonstrate how you would actually go about doing this. So first, clearly we're going to create an Amazon MQ broker. We're going to modify our consumers or create new consumers to consume from both the on-prem and Amazon MQ endpoints. So an example here, and I'm going to show this in a moment with a demo with ActiveMQ, we can use this failover endpoint. So as you can see, there's the old endpoint, which is refers to the on-prem broker, and then the new endpoint. So we use this failover protocol. We set up our consumers using that endpoint. Next, you'll stop each existing producer and point those producers to the new broker's endpoint, and then restart the producer. So now we're starting to produce messages into the new broker. Our consumers are still consuming from the existing broker. And we're going to wait for the consumers to drain those destinations, those queues in the on-prem broker. Once the consumers have drained that on-prem broker, you can stop your broker. And now you'll see, and you'll see this in a moment in the demo, it's fairly quick, but you'll see the consumers now fail over to the new cloud broker and start consuming. So now you've actually got both producers and consumers in your applications producing and consuming into the cloud broker. So all this can be done, in a production kind of context without impacting things. So and then if you want to, this is an optional step, but you can then just remove the existing broker from your endpoint name. So I'm going to show this quickly in a demo. So in this demo, I'm switching from the on-prem to the ActiveMQ broker. So this is my simulated on-prem broker here. These are my simulated producers, and at the top are my two consumers. So this is fairly quick, I apologize, but what I'm going to do here is I've got that ActiveMQ broker, which is simulating my on-prem broker in the bottom window there. I'm creating a producer to start sending messages to a queue in my on-prem broker. So you can see those messages being sent there. I'm going to do the same thing with a second producer, and then I'm going to set up two consumers. So I've got two producers here. I've got a consumer there and a consumer here. So this is just a static environment. This is my simulating the on-prem world today. I've got two producers, two consumers, simulating on-prem apps, and sending to that on-prem broker. So now what I'm going to do is set up that endpoint that I talked about with the failover from a on-prem to the cloud broker. So I'm going to stop this consumer, and I'm going to change the endpoint. So you can see here this failover. That's my local broker there, my on-prem broker, and then that's the endpoint for my Amazon MQ cloud broker. So I've got a variable there. I'm going to set the consumer to use that temporary URL, which contains the new failover endpoint. And I'll restart the consumer. Okay, so now it's connected to both brokers effectively with a failover endpoint and still consuming messages. I'll do the same thing with the second consumer. Okay, so now both consumers are consuming messages still from the on-prem broker, and I'm still producing to the on-prem broker. So now what I'm going to do, I'm going to stop the producers, and this effectively simulates moving them actually and taking those producers and moving them into AWS. So I'm going to stop the producer and have the producer now point to the Amazon MQ endpoint. So you can see the name there, AmazonMQ.US-West2. So now I'm actually sending, and you can see the sequence number starting over here. Now I'm sending messages to my new cloud-based broker. I'm going to do the same thing with the second producer. And you can see the two consumers here have paused because they've now drained the queues in your on-prem broker. So now what I'm going to do is go to my on-prem broker, and I'm going to stop that on-prem broker. So I'm going to just ActiveMQ here, so I'm just going to stop it. And you can see here I've failed over. It was very quick on this consumer, but I failed over. And now you can see from the sequence numbers, I'm now consuming those new messages from the new cloud-based broker. I know that's pretty fast, but that kind of simulates how you would actually move from an on-prem broker to the cloud and move your producers and consumers in a non-disruptive way. So that's one approach that you can take. Another approach you can take is a hybrid architecture. So that in the previous approach, it was really just stopping and decommissioning your on-prem broker and moving directly to a cloud-based Amazon MQ broker. With a hybrid solution, one of the biggest concerns that we see from customers is that they're migrating and all their systems have to be migrated at once, and they feel that's kind of risky. So, and most enterprises have many interconnected systems, and moving all the systems at once can be expensive and risky. And another concern is that sometimes the systems are so old, like they might still be running on mainframes, we see that. So they can't move those to the cloud. So they might have new things in the cloud, they might want to maintain in some permanent way some on-prem environments. And so when you're using a standards-based message broker like Amazon MQ, you can move or bridge actually to your existing on-prem broker. And so this means you can build a hybrid solution, and you can leave some apps on-prem, let's say the ones that run on a mainframe, and move others to AWS. You can either refactor them or you can do the replatform that we talked about. So with a hybrid bridge, all your apps can be interconnected, some remaining on-prem, some others move to the cloud. And this is one of the use cases that's, I think, is quite exciting, and that's enabled by the standards-based aspect of Amazon MQ. And we have that builder session I mentioned earlier on. It's API313 if you want to look it up in your planner. And that will give you exact details on if you want to actually do this. It'll actually show you, and you'll walk through those steps. But at a high level, this is another company we worked with. It was a large telco. We'll just call them any company. And we helped them build a POC. They had their mainframe billing application running on-prem. And, I see the server's not showing up well there. So they're running on an IBM MQ server. They're using IBM mainframe for their billing application. They had no plans to ever decommission that. So what they did, and what we helped them do, is we built this bridge concept using a JMS bridge. And it uses another Apache open source product called Apache Camel. And we helped them set up Apache Camel in an auto-scaling group across 2 availability zones to ensure availability and to ensure HA. So what happens in this scenario is this Camel bridge forwards messages from the IBM MQ queues that are on-prem to the Amazon MQ queues that are in the cloud. And in this case, it was a kind of a one-way forward. You can also do these hybrid scenarios bi-directional. This just happened to be a one-way scenario. So that's an approach you can take if you want to consider doing a hybrid approach. A second option for hybrid, and this can work if your on-prem broker today is ActiveMQ. There's actually kind of a simpler way to do this instead of using the Camel bridge, and that's using the network of brokers feature in ActiveMQ or Amazon MQ. So in this model, you have your ActiveMQ broker running on-prem, and using the network of brokers feature, you set up what's called a network connector between the on-prem ActiveMQ broker and your Amazon MQ broker. And again, it can be single direction or it can be bi-directional. And we do have a blog linked here that kind of prescriptively talks about how to do this and how to set this up with ActiveMQ. And there is actually a Chalk Talk as well, one of the sessions I mentioned earlier, that will walk you through how to use Network of Brokers. So this can be another great approach. With Network of Brokers, what happens is Network of Brokers supports distributed queues and topics. So if you have 2, 3, any number of brokers, you can configure them in various topologies using Network of Brokers. The simplest one I showed here is just 2 brokers connected in a bidirectional mesh. And you configure this network connector between the brokers. The network connector is the parameter you set up in the configuration. Once you have this Network of Brokers set up, a client, so let's say a consumer or a producer, can connect to any broker in the network, and the broker will take care of forwarding messages to whichever brokers have consumers attached to it. So, and the other brokers act like consumers to the initial broker. So broker A is in a network with broker B. To broker A, broker B just looks actually like another consumer. So this is really useful for a hybrid. You can forward those messages from on-prem to cloud or vice versa if needed. And we've seen customers using this to gradually migrate by turning up cloud applications before they kind of turn down their on-prem apps. This is a sample configuration. It's pretty simple. This is just an XML configuration file in Amazon MQ. And so you just add this network connector parameter. We actually have some blueprints that are CloudFormation blueprints to help you get this set up. But just to show you what this network connector looks like, it just has a name. It has a duplex setting, whether it's unidirectional or bidirectional. You give it the URI for the broker you're connecting to. There's some username and password. There's some simple authentication between the 2 brokers. And then you can actually specify, if you want, you can specify specific queues that are going to be connected between the brokers. So that wraps up the presentation mostly. In conclusion, I just wanted to kind of summarize for you. So we talked about 3 strategies. There's rehost, replatform, refactor. Those are 3 broad strategies you can use for migration. And messaging, for your messaging applications, you can also, for your message broker, I should say, you can adopt those 3 strategies. And we dove more into Amazon MQ as a replatform strategy for migration. And that allows you to yield benefits of a reduced operational load by moving to a managed service for your message broker. And we also talked about a few different approaches for doing a seamless migration. So one where you do actually a live migration from your production application to a managed broker and then decommission that on-prem broker. And then we also talked about 2 hybrid approaches, the CAML or the JMS bridge approach and the Network of Brokers approach. And just wanted to finish off with a quote from one of our customers, dealer.com. And they migrated from an on-prem broker to Amazon MQ, so I'll let you read through that. But one of our successes, there's several others as well that are on our website. One of them is Bench Accounting. So they published a blog on their own website about their migration experience from ActiveMQ to Amazon MQ. So I encourage you to check that out. And there's another blog that specifically covers RabbitMQ migration. It was written by Sam Dengler, one of our AWS solution architects. So if you are currently using RabbitMQ today and want to take advantage of managed services, I encourage you to check out that blog as well. Thank you all very much for attending today. I hope you enjoyed the session and wish you all a wonderful reInvent. Thank you very much.